So I'm Neil Brown. This is joint work with my co-authors Eva Marinus and Alita Hubbard-Shoah, who can't be here today. So the positivist approach to science posits that there's a reality which we can reliably observe. Okay, so if our knowledge becomes inaccurate, it becomes useless or potentially even harmful. So how can we be sure that our knowledge of the world is actually accurate? So Karl Popper said we do not even take our own observations quite seriously or accept them as scientific observations until we've repeated and tested them. Only by such repetitions can we convince ourselves that we are not dealing with a mere isolated coincidence. So the suggestion there is that we should replicate our research in order to be confident in the results. So the reproducibility project was a large effort from about 2015 onwards in psychology to replicate some top studies to check that they actually were sort of reliable and that the results held. What happened led to something that you may well have heard of known as the replication crisis. So as author Stuart Ritchie described it, overall the replication crisis seems, with a snap of its fingers, to have wiped about half of all psychology research off the map. So I mean, this is obviously quite a seismic change to their field. A lot of studies that had been sort of taught to students now became just sort of unreliable knowledge. And there are many ramifications. So you may be familiar with the book Thinking Fast and Slow, written by Nobel Prize winner Daniel Kahneman in 2011. And in a chapter on social priming, he wrote, "Disbelief is not an option. The results are not made up, nor are they statistical flukes. You have no choice but to accept that the major conclusions of these studies are true." In 2017, after the replication crisis, he wrote, "Clearly the experimental evidence was significantly weaker than I believed when I wrote it. This was simply an error. I knew all I needed to know to moderate my enthusiasm, but I did not think it through." So I really respect to him for, acknowledging that basically the social priming results didn't hold up. They were one of the sort of major victims of the replication crisis. But I mean, how many here have written books about CS education? Do you want to be in Kahneman's position of having to retract essentially what you have written? We want our knowledge to be reliable so that when we go and disseminate it to educators, to sort of convince people to actually act on it, we want it to sort of hold up, our own research and the research of others. So could this potentially happen in CS education? Might some of our favorite research turn to dust? So we don't have a reproducibility project, to be sure. There's a paper in 2016 by Ahadi et al. Who surveyed CS education researchers. They asked basically, how much of CS education research do you think will replicate? So in psychology, it was 50%. The estimate among researchers, so us in the room, was that only 30% would replicate. So there's clearly a sort of shared opinion that maybe some of the research won't hold up. They also asked them about replication work that they'd done themselves. So 40% had failed to replicate someone else's result, and 48% had failed to replicate their own result. So I think we can say there is the potential for problems with reproducibility in CS education. So what causes these issues? Is it potentially a few bad apples? Am I going to stand up here and name and shame researchers who I think, have contributed to this? No, it's happens to all of us, and we know why already. It's systemic pressures on us. So we're all familiar with the idea of publish or perish, that due to various metrics from our universities, from governments, that we have to publish certain numbers of papers or get certain amounts of citations. That obviously leads to sort of perverse incentives to try and get published. There's a novelty bias that we generally want to try and publish sort of new, exciting results that are going to get a lot of citations and attention, rather than maybe going back and shoring up our knowledge by replicating existing work. There's also a positive bias that when we do our statistical tests, we then think they've got to be statistically significant or there's nothing in the paper. So in order to get published, researchers may turn to something that's been coined questionable research practices, QRPs. So I'm going to lead you through an example to explain some of these. So let's say you set out to study retention rates in your CS class. You've done 1 year with Python, you've done 1 year with C++, and you compare the retention rate. You find that it's not significant. So what are your options with this piece of research? One is that you don't publish it because you don't think it's going to get accepted, or you try and publish it and it gets rejected. So this is something known as publication bias. And it happens both on the author level, because authors don't dare to even try and publish, and on the reviewer level, where reviewers say, oh, basically there's nothing here. You didn't find anything because the result is null. Another possibility is that you say, oh, well, if I at the last minute exclude students who had prior experience of programming, I do see a difference in retention rates among my study. So this is manipulating the statistical tests that you ran, and this is generally known as p-hacking. There's all kinds of ways that you can p-hack. Another possibility is that you discover in your data that there was a significant result when you compared students who used IDEs versus students who didn't use IDEs. So you think, okay, I'm just going to discard my original hypothesis, and I'm now going to write it up as if my plan was to investigate IDE usage, and I found a significant difference in that. So this is known as hypothesizing after results are known, or harking, which is changing the point of your study and not being transparent about it. So it would be okay to say we found a null result in the retention rates, but we did find this, but it was sort of, something we found by happenstance, versus just writing up the paper as if you meant to do that all along. So what kind of results does this have across a field? I'm going to show you a graph here. The y-axis is going to have frequency on it, and the x-axis is the z-value. Intuitively, you can think of this as sort of the extremeness of the result. So we might expect something vaguely like a bell curve. We can't really know the true distribution that should be here, but we might expect that most results should be clustered around 0, which is sort of the neutral or no effect. And then we've got some results out towards the tail, but progressively fewer and fewer that actually are statistically significant. So here the darker blue will not be statistically significant. The lighter blue tails will be statistically significant. And so the graph comes from a meta-analysis in sport and exercise medicine, but it's quite a nice example. So maybe it should look like this. What it actually looked like was this. So there's almost a complete absence of non-significant results in the middle there, followed by a sort of sudden bulge just after the statistically significant threshold. It's sort of impossible to tell from this graph alone if this is publication bias, which is that people who had non-significant results didn't get published, or whether the non-significant results were manipulated and pushed past the threshold, and that would be p-hacking. So you can't really tell from this graph which happened. I suspect it's a bit more p-hacking given the sort of sudden bulge there, but we can't know for sure. But clearly, this then gives a very unrepresentative sort of view of reality in your field. If everything seems to pan out statistically significant, we're not seeing the true picture. There should be more null results in there. So what can we do about these issues? One thing, obviously, is to conduct more replications, and the other is to try and prevent some of these questionable research practices. And for the rest of the talk, I'm going to mainly focus on the second item. So one technique for doing this is registered reports. Registered reports are a new way, or a different way rather, to peer review studies. So this is the traditional sort of pipeline. You design your study, you collect the data and analyze it, you write it up and submit it for peer review, decide whether to accept or reject, and if it's accepted, it gets published. What registered reports does is swap the stages round. So you design the study, then you submit that for peer review, then you collect the data and analyze it, and then publish. What this means is that the accept-reject decision is made earlier, after the peer review, but before the data has been collected. So how does this work exactly? This might be the traditional structure of a sort of positivist statistical paper. You've got your introduction, you've got your methods, you've got your results, and you've got your discussion. For a registered report, you essentially write up the first two sections, and this is known as the stage 1 report. This is then submitted for review and decision. So you're basically judging, is this a worthwhile topic to investigate? Are you using appropriate methods in order to do this? But the advantage is it reduces publication bias. Oh, okay, better hurry up. So because you don't know the results at that stage, they don't even exist. So you can't make the decision contingent on whether it's significant or not. Prevents hypothesizing after results are known because you've stated your hypotheses up front. And it reduces p-hacking because you've declared your methods up front. And so it should be clearer then if you've changed them later on. The full paper is later written up as the stage 2 report, and then it's also reviewed, but mainly as a matter of checking that it compares to the first one and that it's clear and sensible. So I'm going to just skip past a few bits here. So what we actually did was Jan and Brian, who are editors of the Community Science Education Journal, came up with the idea of a special issue with only replications reviewed as registered reports. Jan was conflicted on this paper, incidentally. So the three authors of this paper then acted as guest editors for this special issue. So we basically put it into practice. It's been published June this year. There's 4 papers in it, so you're welcome to go and have a look. The sort of topics were dynamic programming, looking at computational thinking, contribution to group projects, and the hierarchy of reading, tracing, and writing skills. So the lessons we learned from this, there was issues with the timeline. We allowed about 10 months between stage 1 and stage 2. That was not long enough. Many authors needed longer. There's issues with reviewer selection and retention that basically would ideally like to have the same reviewers, but if you're talking about a year apart, that's quite tricky to retain the reviewers. Power analysis. Power analysis is a way to determine what sample size you should have in order to sort of find the effect you're looking for. We wanted to have this, but it's not standard practice in computing education, so we realized it was too much at once to do replications, registered reports, and power analysis. We would have liked it, but we left it aside. Non-positivist research, we are aware of it. There are sections in the paper about it, but I couldn't fit it into this talk. Okay, last slide. So my recommendations, there's a very good book on this I've been reading, Science Fictions by Stuart Ritchie. He does work at King's, but I've never met him, so I don't have any conflict of interest. We should encourage replications with special tracks and awards. ICER has a couple of paper awards. We've got things like the Test of Time awards. Maybe we could have special tracks for replications or particular awards. Just to point out, there should not be contingent on the result of the replication, or else we're back in the same problem we already got ourselves into. We think we should add registered reports to journals as an option. So we don't think this should be the only track. There's all kinds of research that maybe doesn't suit registered reports. This paper, for example, probably wouldn't have worked as a registered report. So, but we think it should be an option and one that should be encouraged for the right kind of studies. So the sort of classic positivist, statistically based research should fit very well to registered reports, and we think that should be encouraged. Okay, but those are options for people who organize conferences and edit journals. I know you're in the room. But for everyone else, what can we do? Well, one possibility is to start pre-registering your studies. So you don't get the advantage of peer review, but what voluntary pre-registration does is you basically take your introduction and methods that I described, you put it up on the Open Science Foundation as a public PDF. Then when you actually, before you do your data collection and analysis, when you then submit your paper, you can say, look, we already pre-declared what we were going to do and it's over here. So if you want to check against what we actually did, then you can do. It increases transparency. It's something everyone can do already. It's a relatively straightforward step, and it may just help in sort of ensuring quality in your research and other people's trust in your research. Okay, and that's me. So thank you very much.